right, we are starting Chapter 6 on vectors. Now this does not mean that we are totally done with trigonometry. The trig is going to pop up as we work with vectors. Let's start with what a vector is. A vector is a quantity that's going to be represented by an arrow, so you can see that here. Vectors are represented by arrows. And this arrow is showing direction, that's why the arrow is on it, but it also, the length of that vector is going to indicate its magnitude. And that magnitude can represent different things. Sometimes it represents length, sometimes force. It just depends on what the problem is dealing with. So keeping in mind that as we draw these vectors, and today we're looking at geometric vectors, so we're looking at drawing them and looking at the geometry of them. Not going to do much algebraic stuff. Going to be going back to protractors and rulers today. Let's try some. We have 10 problems that you're going to do for homework, and 3 of them we're just going to do in our notes. I've designated some vectors. You can see them at the top of your note sheet or at the top of your homework sheet or of your note sheet, but right here we have different vectors. We've labeled it like a vector A, and then you can hardly see that notation, but on top of that, it looks like this. It's like an A with like a half arrow kind of thing on there. That's how we notate vectors. Vector A has a magnitude of 4.5 centimeters, and its direction goes 90 degrees. These directions are based off the unit circle, so thinking 90 degrees is going to be straight upward. We're going to take vector A and we're going to add to that vector B. So vector B has a magnitude of 1.5 centimeters and its direction is 0 degrees. So these are some pretty basic degree measurements or some directions. What you do when you combine vectors together through addition or subtraction is we kind of use this tip to tail kind of idea where we're going to start by drawing the first vector, and I'm just going to sketch this over here. Vector A is going to be going straight up to 90 degrees. So vector A is going to look like this, and it's going to be 4.5 centimeters. And then at the tip of that, that's going to be the tail of my next vector, vector B, that I'm going to add to it. It's going to go 0 degrees, so it's going to go straight to the right, 1.5 centimeters. That's what my drawing is going to end up looking like. What I want, though, is what we call a resultant vector. I want basically how far have I been displaced from my starting point. My starting point was right here, and my ending point was right here. That blue vector right there, that is called our resultant vector, and that's a R with a little half arrow above it. That's ultimately what I'm looking for, is the resultant. But I have to draw it out, and I have to do it super, super neatly because I'm only going to give you a little bit of leeway on how accurate your resultant is. I kind of drew this out so that I would know where to start. As you're doing your homework, some of you might be able to do it on one piece of paper, but more than likely it's going to take you about 3 pieces, and you're going to hope that you don't run off of the paper as you draw it. It's smart to think about what you're going to be doing, even if you have to sketch a little bit. I need to be starting in the lower left because I'm going to be working my way to the upper right. I'm going to pick a starting point way down here. There's my starting point. Now, my first vector, vector A. I'm going to grab this. Now, I'm going to try to do this. We'll see how well this works with my little tools over here. You're going to take a protractor, and you've got to, depending on what your protractor looks like, you might have one that has a little hole in it right here. And if you have a hole or some crosshairs or something, that's where you always line it up. Your protractor, you're always going to set it so that 90 is straight up. Now, once in a while, we might have to rotate it upside down because it's going to need to go to the 3rd or 4th quadrant. But you always keep it horizontal like this. And you're going to keep this, and you're going to line that up with that starting point. I'm going to stick those crosshairs right there in the middle of my starting point. And then I'm going to mark my first vector was at 90 degrees. I have to mark See, I'm going to be off a little bit, and we need it to be super accurate, so I'm going to try it again. You will have better luck on your paper. Nope, looks like it's... Okay, I'm going to go with that. There's my 90 degrees. Now, once I've marked it with my protractor, then I grab my ruler. And my ruler, I'm going to take here, and I'm going to start at that starting point, but it needs to go up. So I'm going to take this thing, and I'm going to rotate it upwards. Sorry, I should be starting that at 0, not at 1. But I'm going to rotate this, see if I can make it rotate. Start it at 0 and make it hit that line. It's going to take me forever to do it like this, sorry. Okay. I need to go up to 4.5 centimeters. So I'm going to draw a line straight up. Now this is, you're going to have to, yours is going to have to be super, super accurate. Mine, you're going to have to give me a little leeway. I'm going to draw a straight line along my straight edge up there to 90. But I have to go 4.5. Now that was kind of a coincidence that my little mark actually hits at 4.5. That's not typically going to be the case. You just draw that line as far as it needs to be, and mine happens to end right there where I need it to be. And then at the end of this, once you have it drawn, you're going to put an arrow at the top. You should be doing this with me. Believe me, it's going to take me long enough to do this that you're going to be able to do it on your own. Holy cow. I want you to label this. This was vector A. So you put an A with that little half arrow thing. Now I'm going to go tip to tail. So the tip of that one is going to be the tail of my first or of my second vector, of vector B. Vector B has to go straight to 0 degrees. Grab your protractor again, always keeping it horizontal. So kind of use the lines of your notebook paper to kind of make sure to keep this horizontal. It doesn't mean that it's going to lie on those lines, but you can use them to kind of make sure that it stays straight. Once you have that lined up, you mark 0 degrees. And then get rid of the protractor, grab the ruler. I'm going to rotate this around, start at 0 on that tip, and I have to hit that line that I marked. Uh-oh, where'd my line go? I marked it on the protractor. That's not going to work. Let's make it a little bit farther out there so it doesn't attach to my protractor. Oh, I know what's going on. I have a little bit of white space on the outside of my protractor, I believe. So I'm going to keep that going just a little bit farther out there. There we go. Okay. Now, grab the ruler. Are you done yet? This time, when I line that up, I can kind of keep that lined up to there, but I really only want it to be 1.5 centimeters long. That's the magnitude of vector B. So I'm going to put a little mark at 1.5. See if I can find that spot. Okay, I'm going to go with that-ish. Okay, that's horrible. I always expect better from you. Okay, this is going to be a very short vector. Using your straight edge, I'm freehanding this, but you use your straight edge and draw it along and make it the right length and put the tip at the end and label it vector B. But ultimately what we want is the resultant, which is the start to finish line. There's a couple things that I'm going to do. I'm going to go ahead and I'm going to draw the resultant first of all. Grab your ruler and let's go put the beginning, the 0, at the starting spot. And let's rotate this ruler up here to hit the tip of vector B. Put 0 at your starting point and then you're going to draw. I like to do it with a red pen or a highlighter, or maybe I just come back and do it, but ultimately this is my resultant there. Okay, if you look at that, while I have it drawn there, because I am looking for this information off of my resultant, and as I have that ruler line up there, I can see that it's 4.7, 4.8. I'm going to go 4.8 maybe on that, centimeters long. That's the magnitude of the resultant. That's going to be important. That's part of our answer. Our resultant is, I'm going to go 4.8 centimeters. I only give you 2/10 leeway on this. It needs to be super accurate. Now, I'm not saying 4.8 is super accurate. I'm going to trust you probably more than me on this particular because of the way I'm having to draw this. But I do have exact answers of what all of those should be. You need to keep it accurate so that your resultant ends up being accurate. The other thing you're going to do is grab your protractor and lay it up here on top at your starting point and keep everything lined up and look at what angle that measurement is. Now you know that that's an acute angle, so I'm not looking at the top numbers on my protractor. Don't be looking at these. That doesn't make sense. It starts at 0. I'm using the lower numbers, and I'm going to go with a 74 degrees. My resultant is 4.8 centimeters at 74 degrees, and that's the direction. And again, you need to be within 2 degrees of my angle. Again, if no promises, these are the exact numbers of what we want, but this is the gist of how you're supposed to be doing this. All right, let's try again. I'm going to go a lot faster this time, hopefully. Let's see if I can use my tools better. I want to start off and I want to take vector C right here. And it's going to be going at 120 degrees. I'm going to sketch this out so I know where to start. If I were to start right here, 120 degrees is like going right this direction. And then what's different on this example, notice this is number 5 on your homework, you're going to be subtracting this vector E. And you're not subtracting just vector E, you're subtracting 3 times that vector. If I look at vector E, its direction is 155. If I want to subtract it, I'm going to go the exact opposite of a 155. I would come from the tip. I didn't put my arrow on. I should have shown direction with that. Okay, that's where that ends. And then I would go to 155, which would be like this direction. Because remember, we line it up horizontal to where this is 0. So 155 is over here. And then I would have to draw the length of vector E, which is 2.5. I'd have to do that 3 times. There's 2.5, 2.5, 2.5. Except that I'm subtracting that. I'm not going to be going this way. I'm going the exact opposite way. It's going to be going like vector E is there, and then I do it again, and then I do it again. My resultant is going to be start to finish right there. All right, so looking at that, it appears that I need to start somewhere around, let's say, I don't know, let's go here-ish. That's going to be my starting point. Don't make a huge dot like I am. I'm just doing that to help you see that. You don't want it to be, so big that it's like a couple tenths of a centimeter wide. That's going to ruin your accuracy. Just make a single dot. And now let's draw vector C. I'm going to grab my protractor, put it at its starting point. I'm going to make a special point to make sure that's in the center of my big old dot there. And I'm going to mark 120 degrees. 120 is right here. Then I'm going to get rid of my protractor. Oh, dang it, it did it again. It's so close to that. Sorry, I have to make this way out here. You, of course, don't have to do that, but I have to kind of stretch it way past that. Somewhere. Right here. All right. Not sure how to move my protractor. There, I got it. Okay. Now I'm going to draw it. so it's the right length. Vector C is 3 centimeters, so rotate that around, put 0 right there, line it up so that it's going to hit your tick mark. 0. Okay, all right, we're just going to have to assume I'm not going to be super accurate. I apologize. All right, I'm going to draw this vector 3 centimeters long. So it's going to go up here, 3 centimeters. You're going to use your straight edge to make sure it stays that long. Put the arrow so that the tip of the arrow is at 3. Get rid of the ruler. That's horrendous. Okay, we're going to go with it. I'm just going to adjust that. Okay, so there it is, 3 centimeters long. We're going to label it vector C. Okay, now I'm going to grab my protractor again. Grab this protractor, but because I'm going to be subtracting and I don't really want to go 155, I want to go the exact opposite, I'm going to take that protractor and flip it upside down. Now it's still got to have that baseline as a horizontal line. And I'm going from the tip of my line there. I know my arrow didn't line up perfectly, but I'm going to go with that. Keep it horizontal. You can see where mine leveled out. You use the lines on your paper to level it out. And then mark 155, going the exact opposite of where we thought it should. So 155 looks like it's about right here-ish. You, of course, will make it super accurate for me. And I'm going to draw my vector there. So take this, let's flip it around the other way so that 0 is going to be on the tip of my vector here. Putting 0 right there-ish. You are putting yours there. But I got to hit my protractor line. So let me rotate it to that-ish. All right, going with that. Now, I have to draw vector E 3 times going that way. That's 2.5, 3 times. So what I'm going to do is I'm just going to mark at 2.5, and then another 2.5 would be at 5, and another 2.5. Don't know how far out there, I'm going to have to get that. And then another 2.5 is at 7.5. So I'm going to mark those. You're just going to put a little dot. All you need is a little dot. I'm having to mark it so that it will stay there when I move my ruler. You put a dot at those 3 points. Once you get those 3 points, then you're going to draw your vector. And you're going to go vector. You're using your ruler to line it up. There's vector E once, there's vector E twice, there's vector E 3 times, and we'll go ahead and call it negative 3E with the little vector notation. That's how long that is. My resultant is this right here, from start to where it finished. Now, it looks like as you do that, you're going to draw the resultant. Again, I like to do it in a different color. I'm going to call it resultant R, and I have to look at where it ends. It looks like it ends at about 5 point, I'm going to go 5.7. So my resultant is 5.7 centimeters at, so get rid of this and let's go figure out what this angle is. Now, we could call this a negative angle because you can see that when you line your protractor up horizontally, it's going to fall in the 4th quadrant. But we typically, with vectors, go ahead and leave everything positive, and we'll go ahead and call it the positive angle that would go down there. Well, I know that it's going to be 180 degrees here, plus another, it would appear to be another 170. So I'm just 10 degrees shy of all the way around. I would say that's at 350 degrees. And there's your resultant. Here's the last example. I wanted to try this one. It's really a pretty basic one, but because the magnitude is not measured in centimeters, it makes it a little bit weird. It says Joe kicks, well, they're kicking a soccer ball, I think, but they kick it at the same time. So neither one really wins. Joe's going to kick it with 15 newtons of force at 90 degrees. He's going to kick it basically straight upward. Whereas Jerry is going to kick it at 0 degrees. So this is like our first problem. But I'm going to draw it, even though it doesn't really do this. It's not like the ball actually goes up and then it goes over. That's not what's going to happen. If this is the point of impact right here where they kick it, and Joe is kicking it this direction while Jerry kicks it this direction, the ball is actually going to go this direction. And that's going to be our resultant, and that's what we want to find out. The only thing that I'm probably not going to draw this one out, I just want to talk to you about how to work with this measurement, because it's not centimeters. Well, you just designate it some sort of a scale. And what I would do with this, I would probably go ahead and say that 1 Newton of force is equal to 1/2 of a centimeter. And if I set that scale, and that might even be on your worksheet that scale is there, then what I'm going to do is I'm going to pick a starting point, and I'm going to use my protractor and my ruler, and I'm going to make Joe's vector, which is going to go up 90 degrees. But since it's going 15 newtons, he's using 15 newtons force, that's 1/2 a centimeter for each newton, so that's going to end up being 7.5 centimeters. That's how far I would draw that up. And then I would just call it Vector Joe. And then tip to tail, I'm going to draw Jerry's vector, which is going at 0 degrees, but he's kicking it a little bit harder. So that vector is going to be a little bit longer. That's going to be 10 centimeters long. And I'm going to name it Vector Jerry. And again, you of course are using your tools to draw this out. Your resultant is start to finish. This resultant tells you what really happened with the ball. The first thing you'll want to do is go ahead and grab your protractor and line it up and see what direction that ball actually went. Now, since Jerry hit it or kicked it with a stronger force than what Joe did, then his direction is going to take a little bit more precedence. It's going to go a little bit closer to a 0 degree than it will to a 90 degree. So more like a 40 or a 35 or something, instead of, it's not going to go directly at a 45. The other thing that you need to find is its magnitude. So you're going to grab your ruler and you're going to go line it up and you're going to go see how long this vector is. But then you have to take that length and you have to convert it to a force, to a Newton force. So I'm just making something up. Let's say you measured it out and it ended up being 30 degrees. I'm sorry, not 30 degrees, 30 centimeters. If that was 30 centimeters, and since 1/2 a centimeter is equal to 1 Newton, if I had 30 centimeters, well, that would be 60 newtons. And that would be the force at which that ball actually got hit. And that's how you would write your answer. You'd say the ball actually went at this degree with this many newtons force. All right. Hope this gets you started. Good luck.